welcome to Math Master. This is Saritha. Today we will discuss about the position of a straight line with respect to circle. Means we have one line. We will be given one line. We have to decide the position of a straight line with respect to circle. Okay. So there are three cases. We will discuss one by one in detail. Okay. So this is a circle and with center C. And the first case is if we have line completely outside the circle. Okay. And we have to assume the distance between the center and this line. You have to remember that distance is always nothing but a perpendicular distance. See, if the distance between the center and the line, this is the perpendicular distance I am considering, and I am assuming this distance as a D. Yes, this is the distance D. Okay. This is the distance between the center and the straight line L. Okay. And we know very well that from the center of the circle to the any point on the circle is always a radius, isn't it? So this is nothing but radius R. Yes. Now, by depending upon the relation between the radius and the distance between the center to the line, we will have three cases. So the first case is if R is less than D, means the radius of the circle is less than the distance between the center and line. So the center and line distance we have considered as a D. If this R is less than D, we can say directly this line, straight line completely away from the circle. Means this line neither touches the circle nor intersects the circle. This line completely away from the circle. Yes, this is the first case. So when the relation is given that radius is less than the distance between the center and the line L, then we can directly say that the line is completely away from the circle. Okay, this is the first case. If you consider second case, that is R is equal to D. R is equal to D means the radius as well as the distance between the center and the line is also equal. Means see, so what he has given in the second case, R is equal to D. Means the radius of the circle is equal to distance between the center and the line. Means both are equal. Means that this line intersects or touches the circle exactly at one point. Means this line is nothing but tangent of the circle. Yes. So if the condition is given like that, radius is equal to the distance between the center and line or equal, then we can directly say that the given line is a tangent line of a circle. Okay, this is the second case. And when you move to the third case, which is nothing but R is greater than D. Yes, what happens if R is greater than D? If this is the line, the distance between the center and this line is D. Like this. What happens? This is the distance between center and the line. Yes, this radius R is greater than the distance between the center and line. So what happens? Then this line automatically intersects the circle in two distinct points. Yes, this is one point and this is one point. So what happens? This line will become a secant line of a circle. Yes, because it is a line and which is intersecting the circle in two distinct points. So when the condition is given like that, radius is greater than the distance between the center and line, then automatically the line is a secant line of a circle. Okay, these are the three different cases. Means these are the three different position of a straight line with respect to circle. Okay. Now we will discuss one theorem which is Pitot's theorem. What is Pitot's theorem? See, if a circle touches all the four sides of a quadrilateral, we don't know what type of quadrilateral it is. What we are just doing, we are drawing a circle which is touching all the four sides of a quadrilateral. Okay, so then automatically what happens? The sum of the opposite sides are equal. Means in this quadrilateral, the sum of the opposite sides are equal. See, if ABCD is a quadrilateral, so AB and CD are opposite sides and BC, AB, AD are opposite sides. So according to the theorem, the sum of the opposite sides are equal. Yes, AB plus CD is equal to BC plus AD. This we have to prove. Yes, so we have to prove that sum of the opposite sides are equal. See, you try to observe this figure. In this figure, so what this vertex A represents? So with respect to circle, if you observe, this A is nothing but a point exterior of a circle. Yes. So the vertex of a quadrilateral is looking like it is a point exterior to the circle. If you draw two tangents from exterior of a point, we know that the tangents drawn from the external points are always equal. Yes. So if these points P, Q, R, S, yes, this AP is one tangent, AQ is one tangent. Yes, so we know that the tangents drawn from an external point to the circle are always equal, which is nothing but AP is equal to AQ. See, and you observe this vertex, B vertex. This is also an external point to the circle. Yes, these BR, BQ are two tangents drawn from an external point B to the circle. Yes, we know that this BR is equal to BQ. Yes, BR is equal to BQ. Yes, and similarly you can write with vertex C and you can write with vertex D. Means CR is equal to CS. Yes, CR is equal to CS. And similarly, DS is equal to DP. DS is equal to DP. Now, what we have to prove? We have to prove that AB plus CD is equal to BC plus AD. So, I am writing AB plus CD. Now, AB. What is AB here? This one, right? So, how can we write AB? Which is nothing but AQ plus QB. Yes, I am writing that AQ plus QB. And CD. CD is nothing but this one, right? So this is nothing but CS DS. Yes, CS plus DS. Now you try to substitute the value of AQ as AP and QB as BR and CS with CR and DS with DP because the lengths of those are equal. Yes. Now you try to see this AP and DP. AP and DP is nothing but AD, right? So AP and DP we can write it as AD and CR, which is nothing but BC. Yes, BC. So what did we get? We get that sum of the opposite sides AB plus CD is equal to AD plus BC. We have proved the Pitot's theorem. Yes. What it represents? Nothing but if you draw a circle touching all the sides of a quadrilateral, then sum of the opposite sides are equal. Means sum of the opposite sides AB plus CD is equal to AD plus BC. Yes. Our next theorem is if a circle touches all the four sides of a parallelogram. See, he has given here parallelogram. In the previous case, it is a quadrilateral. We don't know what type of quadrilateral. But in this theorem, he has clearly given that the quadrilateral is nothing but a parallelogram. Yes, if you draw a circle touching all the four sides of a parallelogram internally, then this quadrilateral automatically becomes a rhombus. Yes, that we have to prove. How can we prove? So for the rhombus, what condition we have? We have a condition that adjacent sides are equal. Yes, that we have to prove. So in a parallelogram, we know very well that pair of opposite sides are equal, isn't it? So AB is equal to CD because it is a parallelogram, pair of opposite sides are equal, and AD is equal to BC. AD is equal to BC. These are the pair of opposite sides are equal in the case of parallelogram. So from this, what we have to find out the conclusion that the adjacent sides are equal, which is nothing but AB is equal to BC or AB is equal to AD. Okay. So we know very well that if a circle touches all the four sides of any quadrilateral, we have a condition that the sum of the opposite sides are equal. Yes, which is nothing but AB plus CD, which is equal to BC plus AD. Yes, so we know very well that AB is equal to CD. Yes, we can write it as AB, and we have to substitute AB in place of CD, which is nothing but AB. BC, and we know AD is equal to BC. We have to substitute BC in place of A. Yes, now I will get 2AB is equal to 2BC. So 2 gets cancelled. AB is equal to BC. See, you observe, this is AB, this is BC, which are nothing but adjacent sides are equal. So where we have that condition? We have that condition in the rhombus. In the square also adjacent sides are equal. But in the square we have an extra condition that the all angles are equal and each measures 90 degrees. But here we don't have any condition on the angles. We don't know exactly what each angle measures. That is why we have only one condition that adjacent sides are equal. So by having this condition, we can directly say that the given parallelogram is nothing but a rhombus. Yes. Next theorem is, if a circle touches all the four sides of a rectangle internally, then it is a square. Means we have to show that all adjacent sides are equal, along with that all angles are equal and each measures 90 degrees, then it will automatically equal to square. Yes, as this ABCD is a rectangle, he has given that he has considered a rectangle and he has drawn one circle which is touching all the four sides of a rectangle internally. We know the condition in the rectangle that the pair of opposite sides are equal and all angles are equal, each measures 90 degrees. Yes, these are all 90 degrees and pair of opposite sides are equal. Yes, from this we have to conclude that adjacent sides are equal, then automatically it will become a square. So in order to prove that, we have a condition that if a circle touches all the four sides of a quadrilateral, the sum of opposite sides are equal. Yes, we have to write that condition first. AB plus CD, which is equal to BC plus AD. Yes, we know the pair of opposite sides are equal in case of rectangle. Yes, so you have to substitute AB in place of CD. Yes, AB plus AB, and you have to substitute BC in place of AD. Yes, so you will get 2AB is equal to 2BC. Yes, 2 gets cancelled. AB is equal to BC. So AB is here, BC is here. These AB and BC are nothing but adjacent sides. So we have concluded that adjacent sides are equal and each angle measures 90 degrees. All angles are equal. We have this condition only in square. Yes. So we have seen three theorems. First one is Pitot's theorem. The Pitot's theorem, we don't know which type of quadrilateral it is, but a circle touches all the four sides of a quadrilateral internally, then sum of the opposite sides are equal. So this is in case of quadrilateral. And the next theorem, if we have a parallelogram and a circle touches all the four sides of a parallelogram internally, then automatically it becomes a rhombus. And the next theorem, if we consider a rectangle, if a circle touches all the four sides of a rectangle and the internally, and the quadrilateral becomes square. So these are the three theorems we have discussed, and we will continue the next topic in the next video. Thank you.